Hey class, Mr. Houston here, back for another exciting episode of Geometry Notes. Today we are taking a look at Chapter 1, Lesson 2. We're going to start talking about segments, and we're also going to talk about congruence. Again, I want to draw your attention here to the left-hand side of your paper over here. Again, vocabulary words located here. A couple of things that you need to know, especially with geometry. We have a postulate or an axiom. It's a rule that is accepted without proof, meaning we don't have to prove that it does work. It's accepted and everybody accepts it. And then there's a theorem, and that's a rule that can be proved. We'll talk more about theorems here as we move towards Chapter 2. A coordinate, real number that corresponds to a point. Think of like a coordinate plane. Distance, this is key. This is a big one. This is one that lots of kids get wrong. Distance. It's an absolute value. And what I mean by an absolute value, I mean that it is always going to be positive. The only negative distance I think I've ever seen is when I try to swing a golf club and that ball bounces off of a tree or something, bounces behind me. It still travels a distance, so distance is always positive, even though it seems like we're going backwards. Okay? And then down here is congruent segments, line segments that have the same length. We're going to talk about all this here in the notes. So first postulate. Postulate number 1 just simply talks about, it's called the ruler postulate. And basically what that means is that the points on a line can be matched 1-to-1 with real numbers, and that the distance between points is the absolute value of the difference of the coordinates. So basically it allows us, if we look at example 1, to take this line segment here, place a ruler on it, and measure from here to here. Now, however you choose to do that, some people obviously would probably try to line it up so that it starts here and then extends that way. But we didn't do that here. We brought it down to the 2 and to 5.5. So in order to determine the length of line segment ST, we have to find the difference of the two coordinates that it works with. So in this case, you could do one of two things. You could take this and this. First off, before I get too carried away, what does difference mean? Hopefully you know that that means to subtract. So two ways of doing this. You can either do 2 minus 5.5, or you can do 5.5 minus 2. I prefer, I'm not saying it's the only way to do it, I prefer this direction, taking the larger number and subtracting the smaller number. Because when we do that, you'll do 5.5 minus 2, and you'll get 3.5. Okay? Now over here, on this one, 2 minus 5.5, you may have to plug that into a calculator, but 2 minus 5.5 will give you negative 3.5. And that's where this word right here, these words right here, comes in, the absolute value. Absolute value just means that it is just never negative. So this would give you positive 3.5 as well. Okay? Again, most people would have put it on the line starting here. We didn't. So you subtract the coordinates to figure out the length of that line segment. Should hopefully be nothing new there, just kind of seeing it a little differently. Okay, example number 2. Some of these postulates are very, what's the word I'm looking for? They're very obvious. So like here, the segment addition postulate. I mean, it's in the statement. It is there. It's segment addition. Basically, if I have point B is between A and C, then I can add 2 segments together to get a bigger line segment. And then there's also the kind of the opposite of that. If I add 2 segments together and they have a common point, then that point has to be between the other 2. So just some things to keep in mind. I would highly suggest, if you have a highlighter, maybe take a highlighter and start highlighting all of these postulates and everything like that you have on here, because we are definitely going to use them as time goes on here. Okay? So let's put into use the segment addition postulate. Example 2, the cities shown on the map lie approximately in a straight line. Use the given distances to find the distance from Lubbock, Texas to St. Louis, Missouri. I hope I pronounced that right. So we're trying to go from here to here. We know from Lubbock to Tulsa, it's 380 miles. We know from Tulsa to St. Louis, it's 360. So if I want to figure out the distance straight from Lubbock to St. Louis, all I have to do is use the segment addition postulate. So I'm going to take 380. I'm going to add 360. Again, I got those distances from here and from here. Simply add those two together, and you should get 740 miles. I'm a stickler for labels. If there's words in the problem, like we have here, you should have a word in your answer. In this case, it's miles. You could even abbreviate it if you wanted to. So that's the segment addition postulate. All right, go flip over to the back side here. So kind of the opposite, not the opposite, but almost like the inverse of the segment addition postulate we can use to do example number 3. It says we want to find the length of line segment GH. So we want to find the distance from here to here. So if I know the entire distance, and then I know a distance part of the way, how do you think I could figure out the rest of the distance there? Hopefully you're thinking, if I have the whole and one of the parts, I can subtract to figure out the other part. So let's subtract. We are going to take 36 minus 21, and that's going to give us our line segment of GH. 36 minus 21 is 15. So GH is equal to 15. So you're still using the segment addition postulate. If you want to see how the addition part of it would look, you would say something like 21 plus GH is equal to 36. Then you would subtract 21 on both sides, and you would say GH is equal to 15. Either way is fine. This shows the segment addition postulate. This is where we kind of know how to do already. So I'd be quite all right with either way. All right. And last but not least, example number 4. Compare segments for congruence. So there's 2 ways to do this. There's the long way and there is the short way. I am okay with either way as long as you can get the correct answer. It does not matter to me. So you are given 3 points here. You have J, K, L, and M. And what they are asking you is they want to know if JK, so from this point to this point, is the same as this point to this point, LM. They want to know if the distance is the same. So you got 2 options. One option, and I've already kind of done it here for you, is to draw out a coordinate plane, plot your points, connect your dots, and then it's as simple as just counting how far one is away from the other. So if I'm going from J to K, I can go, this would be 0, 1, 2, 3, 4, 5. So JK is 5 units long. LM, again, start at 0, 1, 2, 3, 4, 5. Again, that is 5 units long. So the answer to this question would be yes. They are congruent. But let's just say you don't really care to draw everything out. You'd rather kind of do it mathematically so you can see whether it works out in math rather than counting out points. So let's just take a look at JK first. What you're going to want to do is you're going to want to look closely, and when they have a coordinate in common, you're going to cross it out. So in this case, they have the 4 in common. We want the -3 and the +2. What you're going to do there is what we did on the front page, and you're going to subtract them. So for JK, we're going to take the absolute value of the difference of those 2 points. So -3 minus 2. Now again, we're doing absolute value because distance is never negative. So what we'll get there is the absolute value. Negative 3 minus 2 is negative 5. The absolute value of negative 5 is positive 5. Oh, looky there. It matches. That's good. Now let's do the same thing for LM. And I'm going to back that up just a little bit so I can see that I have the ones in common. So we're going to cross those off. So for LM, we're going to take the absolute value of 3 minus negative 2. Anytime we go minus a negative, I call it the boom boom. We're going to make it that plus a positive, so we get the absolute value of 5. Now remember, absolute value means the distance, so it's not going to just change the sign. If it's positive 5, it's going to stay positive 5. And lucky for us, that matches up there. So we still have proven our answer whether we do it by math or by counting. Okay? All right, so that's how we use segments and congruence. If you have any questions, please bring them with you to class, and we'll see you then.